In this video, we want to calculate the range, variance, and standard deviation for the data here presented to us. This is data that you have already seen. We are told that floor 1 and floor 2 followed or counted the number of patients they received on a weekly or during a particular week. Floor 1 had this number of patients here, 9, 9, 10, 10, 11, 12, 13, and floor 2 over that 7 days had this amount, 2, 2, 3, 10, 12, 20, 25. We saw that when we calculated the mean for both of these, we got about 10.6, and we rounded that to the tenths place. And we found that to be interesting because if you look at floor 1 versus floor 2, they definitely appear to be quite different. Floor 1 is very close to this mean of 10.6. A lot of these values are close together. You know, from the minimum to the maximum, there's a smaller distance. And floor 2, there definitely seems to be a little bit more spread in this data. And it seems to be a little bit more spread out. And we saw that the mean being equivalent, these means being equivalent to one another, didn't tell us this information. We see it with our own eyes here, but the mean isn't telling us. It's not saying anything about the spread of the data. So that's why we need to have some measures of variation to tell us how much spread is in this data. The most popular one, and when I say popular, it's probably the one that's the most used in early mathematics courses, is called the range. And this can be calculated by taking the maximum value in the data set and subtracting the minimum value. So we're finding the difference between the maximum value and the minimum value. So for floor 1, the maximum value, the maximum value we see is 13. The minimum value was 9. That gives us a range of 4. For floor 2, we had a maximum of 25 and a minimum of 2 patients. So when we find the difference between those, we get 23. This is probably the most simple measure of variation. It's simple calculation, and it tells us the distance from the minimum to the max, so it gives us an idea of how far away the minimum and the maximum are from one another. And you can see the minimum and the maximum are quite close together with floor 1, and the minimum and the maximum are quite far apart, 23 patients apart, for floor 2. What we want to do next is to calculate the variance and the standard deviation, and I'm just going to do this for floor 1. You're going to find here as we go over this, there's actually a little bit of a process. It tends to be a little tedious to calculate this by hand. So we're going to use technology, but I do want to show you how it is calculated. Thankfully, when we do calculate the variance, to find the standard deviation, we just take the square root of the variance, and that gives us the standard deviation. So these two measures are related to one another. The variance is the standard deviation squared. So if you take the variance, take the square root, you get the standard deviation. If you take the standard deviation and square it, you get the variance. So that's how they're related. To do this, there's a 5-step process where we need to take each of the data values. And again, I'm only going to do this for floor 1. So I'm going to take each of the data values, 9, 9, 10, 10, 11, 11, 12, and 13. And what I want to do is to take each one of those values and subtract the mean. So I'm going to subtract the mean from each one of these. So you can see I took, or I'm about to take, each of the values, 9, 9, 10, 10, so forth, all the different observations, and I'm subtracting the mean from that. So I'm going to pause the video and fill those all out. So you can see what we get when we subtracted the observations. We found the difference between the observation and the mean. We get 4 values that are negative, and that makes sense because these observations are less than the mean. And we get 3 values that are positive, and these are the 3 values that were larger than the mean. So we're going to take these differences here, and we're going to square them. So I'm going to take in my calculator, negative 1.6 squared. And I'm going to do that 2 times because we have 2 values. I'm going to take each one of these values and multiply by itself. And what this is going to do, it's going to take all the positive, or excuse me, all the negative values and make them positive, and the positive will also remain positive. So that's what I'm going to do now. I'm going to take each one of these and square them. And instead of going through each one, I'm going to pause the video, do them, and come back and they'll be done for us. So I went ahead and squared all of the values, and you can see what we got here. We got 2.56, 0.36, 0.16, 1.96, and 5.76. So these are the squared differences between our observations and our mean. The next step is to sum all of these together. So I'm going to, in my calculator, add all these together. So let's do that now. I got a sum of 13.72. So let's think about what this is. This is the sum of the squared differences between the observations and the mean. We're almost there. We now want to take this and divide it by 1 minus the sample size. So we look at how many observations we have. We have 7, so our n, in this case we say n is 7 because there's 7 data points, there's 7 observations. We want to take 1 minus that. So if we subtract 1 from that value, we get 6. Now this is because we are dealing with a sample. This is a little bit beyond the scope of our course now, but if you go on to take statistics, you'll learn a little bit about the differences between a sample variance and sample standard deviation and the population variance and population standard deviation. So what we're going to do is take n minus 1. We're going to divide by 1 less than the size of our observations. So if I take 13.72 and I divide it by 6, I will get approximately 2.29. 2.29. We finally have arrived at our variance. This is our variance, 2.29. Our variance is 2.29. And now what we want to do to find the standard deviation is to take the square root of this. So if we take the square root of 2.29, let's see what we get. I got approximately, let's turn on the marker. I got approximately 1.51. So this is the standard deviation of floor 1. So you can see this process took some time. We had to take each of the values, subtract the mean, square that difference, add them together, divide by 1 minus the sample size, and then if we wanted to find the standard deviation, which is definitely more popular and we are going to be using moving forward more than the variance, the standard deviation, we had to take the square root of the variance. So we're going to now calculate the variance and standard deviation using Google Sheets, and we're going to do that for floor 2. But before we do that, let's just think about what we might expect. Floor 1, we see there is less variation. The values are more clumped together around the mean. Floor 2, there's more variation. The values are definitely further apart, further away from the mean of 10.6. Most of the values in floor 1, 9, 9, and 11, 12, 13, and all the 10s, they were pretty close to 10.6. But floor 2, they're pretty far from 10.6. There's going to be more variation. That means I should expect to find a variance and standard deviation that are larger. If these are measures of variation, they're telling us something about how spread out the data is. Floor 2 is more spread out. I would expect the variance and standard deviation to be larger for floor 2. So let's take this data now, put it into a Google Sheet, and see how we can use the functions and commands to calculate the variance and standard deviation. So I've gone ahead and entered the data for floor 1 and floor 2 into a Google Sheet, floor 1 in a single column and floor 2 into a single column. What I would like to do is to show you how we can calculate the variance, standard deviation, and then the range for floor 1 and floor 2. But let's do floor 2. Remember when we did the mean and the median and the mode? We went to a cell and we had to tell the Google Sheet that we wanted this cell to be equal to a particular amount. So we start by going to a cell. So I labeled variance floor 2. Right next to it is a cell, and I want this cell to be equal to, and the function that I want to use in this case is the variance function. So if I begin to type variance for VAR, we see that is the function that I'm looking for. That's the variance. We're going to open up a parenthesis, just like we did with the mean, median, and mode. I'm going to select the column that I want, close the parenthesis, and hit enter. We have a variance for floor 2 of 83.95 approximately, which is significantly more than the 2.29 that we found for floor 1. So floor 2 definitely has more variation. We can do the same thing with standard deviation, but we could take the square root of this value, right, and then get the standard deviation, but we can actually have Google Sheets calculate the standard deviation for us by hitting equal to and begin to type standard deviation. So ST, and there it is, STDEV. So if I click on that, or if I continue to type STDEV, I'll select floor 2. After I open a parenthesis, select floor 2, close the parenthesis, hit enter. The standard deviation of floor 2 is approximately 9.16. Finally, the range, there is no formula here for range. But what we do know is the range is just the maximum minus the minimum. If the data is already ordered, like we see here, floor 1 and floor 2, it's already in ascending order, it's pretty easy to calculate the range. We don't need to have Google do it for us, right? Because you just take the maximum minus the minimum. But if you have data that's all over the place and it's not ordered nicely, we can tell Google to calculate the range using two functions, using the maximum function and the minimum function. So we want this cell to be equal to the max, and I'll open my parenthesis, the maximum of floor 2, and then I'll close my parenthesis, minus the minimum. Open the parenthesis, click on floor 2, the column for floor 2, and then close parenthesis. So I'm actually using two functions. This will be equal to the maximum of this column minus the minimum of this column, and when you hit enter, we get 23. So we already know what the variance, standard deviation, and the range are for floor 1. We calculated those by hand. But if you want to pause this video right now and try them on your own, go ahead. I'm going to do that right now. So we put in the variance of floor 1. We get about 2.28 or 2.29, which is exactly what we got. The standard deviation, oops, I forgot to put in my equal to, standard deviation of the column A, or floor 1. I get about 1.51, which is what I got. And the range will equal the maximum of floor 1, close parenthesis, minus the minimum of floor 1, close parenthesis, 4.